Hello everyone, my name is Borja Denis. I'm a researcher and professor of the Universidad Politécnica de Valencia in Spain. Today I will talk about troubleshooting general and specific uses of ground source heat pump systems. Thank you for joining. In this module, we will learn how to find and fix problems in ground source heat pump systems. First, we will see how each part of the system works. Then, we will cover troubleshooting for 4 areas: air side, water side, electrical side, and refrigerant circuit. We will also look at general system problems and also specific uses for the 3 types of loops: vertical boreholes, horizontal boreholes, and groundwater. By the end, you will know the main step to diagnose and solve the most common faults. This slide shows the 4 main parts of a ground source heat pump system: the air side, the water side, the refrigerant circuit, and the electrical components. They are all affect each other. For example, a low airflow on the air side can change the water temperature, disturb refrigerant pressure, and increase the electricity use. To work properly, every part must run correctly and in harmony. The first part is the air side. When the airflow is too low, check these points. 1. The blower wheel. Is it turning fast enough? The motor tap speed or motor side may be wrong. 2. The ductwork. Are filters dirty? Are fire dampers closed? Are there any toll or buses blocking the duct? 3. The duct side. Too small ducts cause big temperature difference, noise, and unhaven rooms. 4. The motor tap. Motor control airflow by the amp drum. Make sure the correct setting is used. And finally, the cold supply are in the cooling mode often means low airflow. Check the motor setting first. But also, too much airflow causes issues too. For example, oversized ducts, large trunk or branches can overload the blower. Leaky ducts, unsealed return duct in unheated spaces waste energy and comfort. And finally, a poor installation. Underside of badly styled ducts cause noise, uneven temperature, or low water side temperature difference. Always measure blower amperage and inspect the duct sealing. Now we are going to move to the water side. If the water pump cannot give the right flow, system performance drops. Look for low flow from ground pipe size, PP restriction, or low inlet pressure. No flow from brown faucet, air locks, seated shaft, or poor suction in pressure systems. Ground fluid temperature when the ground lobes are too smooth or pipes touch soil properly. And finally, cooled heat exchangers in open loop system. Mineral or sand can block them. In the electrical side, the more typical troubleshooting are electrical faults hard to find because of complex wheeling. We recommend a ground source heat pump maker training. Always start with basic inspection, look for broken board or loose wires, brown faucets, triplet breakers, and correct wiring per manufacturer diagrams. If all basic check pass, take lookout relays, solenoid valves, transformer, on other parts. But please follow the manufacturer documentation at every step. Related to the refrigeration circuit sorting, most fouls end up affecting the refrigeration circuit, but user know. Fish, air, water, and electrical uses first. Often refrigeration returns to normal. Only then install and use gauge to read refrigeration pressure, suction, and discharge. Compare the reader to the marker specification. The table on the slide lists the common refrigeration malfunction and their case. Now we're going to see the general system troubleshooting. Here are the most common wall system problems. First, the water leaking, usually at the condensate drain. Check that the line is clear, has proper lobe, a single tap, and no flow. Other one is the short cycle. Equipment too large for the load. It's run on and off quickly. Cut the submissive Python and short the line. Use two-stage or modulating units. Finally, the continuously operation. Equipment of the growth loop is too small. It's never reached the set point, waste energy and reduce the consumption. Recheck the load calculation, the equipment season, and the borehole loop design. This slide shows the troubleshooting guide from the HISPA. It can be used as a reference for the best practice and troubleshooting. For vertical borehole heat exchangers, the issues that we have to face are the following. General issues: a low heat exchanger efficiency from the growth resistance, clogging or U-tube short circuits, flow reduction from the air pocket or scale, fluid freezing from the low antifreeze sheet mist. About the specific uses, we can find poor growth backfalling, thermal breakthrough between nearby boreholes, and peak leaks occurs from the drilling damage or freezing that cycles. For the horizontal lobes, we can find the following general issues: reduced heat exchanger from shallow pipes, seasonal swings, short convections, or uneven loop temperature from unbalanced pipe. About the specific uses are pipe damage by the excavation, reduced soil conductivity from the dry condition, or water table change, and road intrusion around the pipes. Finally, for the system that use groundwater, we can find the following general issues: declining water quality, scale of bacteria, pump cavitation or failure from bronze season or are inland, and uneven groundwater flow. About the specific uses, we can find problems about the thermal plume interference, if radiation is too near to the station, aquifer drawn from overuse, and well clogging by sediment or biofouling. And that's all. Thank you very much for your attention. I hope this session was helpful. And if you have any questions, please put them in the course board. Thank you.